In this video, we will find and interpret an area under the normal curve. In this problem, we're told that the number of chocolate chips in an 18-ounce bag of chocolate chip cookies is approximately normally distributed, with a mean of 1252 and a standard deviation of 129 chips. Now, I've highlighted this phrase, approximately normally distributed. What that's really telling us is that we can use the normal distribution to get a sense of this distribution with this mean and standard deviation. So what I'm going to do now is switch over to our e-text, and this comes from section 7.1. So this is back a section, and objective 3, the properties of the normal curve. There's lots of places that you can find this graph of this normal curve, but notice that the mean is here at the center, and we use the standard deviation like a yardstick to mark important points above and below the mean. If I scroll all the way down here, we can also use the empirical rule. Remember, this empirical rule helps us see the area under the curve between these important tick marks that you can place. Again, the mean being at the center, and using the standard deviation to go up 1, 2, 3 standard deviations or down 1, 2, 3 standard deviations from the mean, from the center. Going back to the problem, you are given this table of values under the normal curve, but honestly at this point you've seen some technology being used as well. So any place that you can, I highly encourage you to use the technology to continue this problem instead of that table of values. So let's look at some technology. We're going to go to StatCrunch. So in the standard StatCrunch screen, what we can do is go to Stat, Calculators, and Normal. Remember, we were told that this was approximately normally distributed, so that clues us in that we can use this normal calculator. The way that it's first presented is actually the standard normal curve with a mean of 0 and a standard deviation of 1. But the mean and standard deviation you were given in this problem should go in these two spots. So let's type those in there. Okay, so now I've updated these values with the mean and standard deviation given in the problem. So let's go back to that problem and let's start answering some of these different parts. The first one is, what is the probability that a randomly selected bag contains between 1,100 and 1,500 chocolate chips? So coming back to StatCrunch, we'll select between, and then down here underneath the probability statement, we'll place 1,100 and 1,500 into these two places, these spaces here, and then click compute. I really like this particular technology because not only does it compute that value for us, but it also gives us a sketch of what that looks like as if we were sketching this by hand, but much simpler and much faster. So we could take that value there and plug that back into our answer space here for part A. B and C are just a little bit different. I'm just going to do part B for this particular video. C has a similar feel to it inside StatCrunch. We're told here in part B that the probability a randomly selected bag contains fewer than 1,000 chips is, so we're going to go back to our normal calculator and then we're going to select standard this time. Notice that the probability statement down here at the bottom has changed, and we want fewer than, less than or equal to 1,000. Sorry, extra 0 there. And compute, and that gives us the value that we're looking for to put in the answer space for part B. Again, C is similar. We would just have to change the direction of that inequality sign in that probability statement. Part D is a little bit different though. This one says a bag that contains 1,025 chocolate chips is in the blank percentile. So percentiles, remember, were area under that curve and to the left of a given value. So let's go back to our normal curve here. I'm going to update this value. And finding a percentile is the same as finding the probability that the random variable x is less than or equal to 1025 as given here in this particular problem. That's how we can obtain the fourth percentile. It's the same as the area under the curve and to the left of 1025.